Witam po przerwie.
Welcome after the break. We are about to start the session, the workshop session. We've got two workshops in this afternoon. The first one, Tomas Lendvorsky, road rehabilitation with Autodesk products. The floor is yours.
My name is Tomas Lendvorsky. I'm working as a technical sales specialist in Autodesk. I'm based in Prague, and I'm responsible for Eastern Europe. And the session today will be about road rehabilitation. And I would like to give you overview how you can utilize Autodesk products for road rehabilitation. From the very beginning, from processing survey through design, and also I would like to show you how you can predict the behavior of traffic while you are closing the roads. So first, I would like to give you my view how I see road rehabilitation, and this is not based on my experience, but it's also based on the experience of our customers. Road rehabilitation is usually very tight in budget. It's not a big project as far as money is concerned, but it's sometimes very time-consuming because you have to meet different standards. And of course, country standards and so on and so forth. But also you have too many constraints, you know. So if you are rehabilitation road, so you have junctions where you have some constraints. You have the bridges, which will not be reconstructed. If you are going through village, you have entrances to different yards and houses and so on and so forth. And designer has to constantly prioritize different alternatives, you know, and he has to think what will be the cost, what will be the benefit, and this is why it's becoming very time-consuming. And you know, there is always obviously not one solution. There are different solutions, and it's always balance to find the best one. And you don't have definitely one typical sections for rehabilitation, because as you are following some constraints, you have to change it. And in many cases, I can see that people are using some CAD software like AutoCAD plus Excel plus of course Brain. And this is what we can change with our solution, because if you look to rehabilitation, it has always some workflow, you know, with some decision-making process, and this is what, in fact, we can do in our products. So with that, let's have a look which agenda you can expect. And it was, in fact, it was already said, you know. So I want to show you how you can process in Autodesk products existing conditions, you know. So if you are survey, obviously this is the part which is important for you because you learn how to work with different data and prepare it for designer. But obviously, designer can also be interested in this, because in many cases they are receiving, let's say, raw data, and they have to process it as well. Then I would like to talk about road rehabilitation itself, you know, so how to make design and what to utilize from our portfolio to make really design of rehabilitated road very fast. And last portion will be about traffic simulation, because in fact, if you are thinking about road rehabilitation, it's always about some road closure, which is causing problems to the drivers. And it's always good to have overview which part of the road should be closed and what will happen around. So with that, have a look at what I want to present you, which workflow I will cover. Autodesk has different products, and obviously different products are meant for different personas. So if we are talking about road rehabilitation, I will be talking about 3 products, but honestly, you don't need to use all of them. Depending if you are a designer, you use only AutoCAD Civil 3D. If you are a surveyor, then Recap and InfraWorks might be for you as well. So I will talk about processing capture data, because if you are talking about road rehabilitation and you want to make really good design, you need good data. And nowadays it's much cheaper and much faster to use point clouds, and I will show you how to process it and how to extract different features, because at the end of the day, point clouds is just millions and millions of points, which for the road designer is not necessary. So we will learn how to extract the features which are important for the road designer. And then I will show you how you can really create rehabilitation, we call it rehab corridor. What is the process to work with alignment, profile, corridor, and how to optimize the design, how to find, let's say, weak spots on your design, how to analyze it, and how to really make let's say, this iteration of the process much faster, because I mean, if you are talking about rehabilitation, you will not be able to make it just one iteration and it's done, because you will learn that, okay, this is better solution. But with our software, with our solution, you can do it definitely much faster. So let's have a look how we can process existing conditions. So if we are talking about existing conditions, and I mentioned it, this is about capturing data, laser scan, and getting really good sample of existing road. Then we have software to compute it, and then we have software to create a design, and we will be talking about AutoCAD Civil 3D. And if I look to a survey workflow, so you have what we call at the beginning raw data. Basically, you have data from different scanners, laser scanners, and you need to process this. And this is why we have software called Recap, which is capable of, let's say, consume different file formats, index it, and maybe you need to clean it, you need to put together different scans. So this is also possible in Recap. And then Recap can export file format which is readable by our software. And of course, now I'm talking about infrastructure, but this RCS and RCP files, they are also readable by Revit, which is for building design, by Inventor, which is for manufacturing design. So this is solution which we have Recap for really processing laser scans. And then you can utilize InfraWorks, because if you have this file format which is usable by our products, you need to process it in a matter of extracting data. And I'm talking about creating existing terrain, basically surface, which you can use later on in Civil 3D, having horizontal features like edge of the road, edge of the pavement, bottom of the ditch, depending how far you have scanning. And also, if needed, there can be vertical object extraction, like if you have some lampposts or traffic signs which you want to see in your design. So all that kind of stuff you can do in InfraWorks. And then you can bring it to Civil 3D for road rehabilitation design. However, you can also bring to Civil 3D classical survey. And it can be in fact combination, because you can imagine that some part has been processed by laser scanning, but then Lendvorsky went outside and he did some other measurement, you know, so which was necessary, and you want to put everything together. And then you can go and you can process it in Recap Pro. So let's have a look what you can do in Recap Pro. So basically, what you can create a new project because you have different files which you want to bring in. And now I have just a few files which I want to bring in, just simple drag and drop, and system will process it, you know. And what you can also do is at the same time you can make transformation, because maybe lens severing has been done in different coordinate system, so you can convert it to coordinate system which is needed for the design. So regardless which coordinate system has been used by lens sever, you can convert it using Recap. And now you can see all files, so system is indexing it, and of course it will take some time, but after some period of time, when the files are indexed, you can start to work with this. And you can see, yeah, it will take a little bit, but then you have data in, and you can start to work with this. So you can see that you have laser scan, obviously, and the surface of the road is, let's say, the best one, but you can really smoothly work with a huge amount of the data. And if you have also maybe some tunnels, some underways, overpasses, and so on and so forth, all data are included here. Yep. So you can see it's really a huge amount of data. And then what you can do is you can bring this point cloud to InfraWorks, and you will see soon why. What you see here is something which has been created from publicly available data, from GIS data, and so on and so forth. So you can take it as some kind of background that you know where you are, if everything is correct. But the system will be really processing point clouds as a point clouds which we will bring in. So having this, so just bringing again using, as I said, RCP, so you can open it and you can bring this data in, you know. So, and just InfraWorks is keeping, let's say, live connection if, let's say, RCP file would be changed. So you can just refresh it later on, because you can imagine that you will start to work with the project and not all data are still available. So you can work kind of step by step, and you can enhance or enrich the data with additional data. Now you can see that you have all necessary information in. And then if we have this, we can start with terrain extraction, which means that having point cloud, you can see it here, and InfraWorks has the functionality to really extract the data. You just see here the difference between publicly available data, which are not, of course, very precise, and laser scan, which is very precise. So you can see the differences. But now you can define what we call processing rules, how the data should be processed, you know, what should be included, what not. And again, this is the automated process, which obviously will take a little bit. However, after relatively short period of time, this is not like that you would have to wait hours for this. You will get a new surface, which you will see here. Yeah. So basically, you have here terrain and terrain overlay, you know, so information, available information. But then in InfraWorks, you can work similar like with layers in AutoCAD, of course, you can make something visible, invisible, whatever you want. This is really up to you. And you can check what's going on your project. And you can see, yeah, nicely. It's a really long piece of road, dual carriageway with information. You know, you can see there is also some noise which has been, you know, because measured because there was a car passing by when measurement has been taken. But this is advantage of infraRoads because he will get rid of this noise. And then you can start with what I call semi-automatic way of creating horizontal feature lines. As I said at the beginning, you know, edge of the road, road center line, because this is what is important for designer. So you can set up the color that, of course, you will be able to recognize it. And just you have to click point at the beginning, then another point that the system will recognize what is this line. And then this is what I call semi-automatic way because you are clicking just twice. But then you can see that the system extracted here. You can see in this part of the road center line very far away, you know. So, and of course, if you would be on the main road, it would be even more. So system can recognize it automatically. There is, let's say, automatically intelligence at the background, and you can continue. So now let's talk about, here is the beginning of another lane. So this is the edge of widening lane. And again, you know, you can see that the system extracted it here pretty far away because it goes all across entire, not entire, but a big part of this laser scan. And obviously you can continue further and do more and more. Yep. So at the end, you will have more feature lines, more, let's say, horizontal feature lines, and you can, let's say, work with this. And what you can also do is you can go and you can create cross sections. Because then you will be making road rehabilitation based on these cross sections, and then what you can do is you can create this here that it will be much smoother designing across the in Civil 3D. But you can also check what's going on because it's a semi-automatic way, and if there was making these feature lines, and you can even add here a new one, you know, so you can say, okay, maybe I want one feature line here, I want another feature line here, so it's maybe some curve, and then basically you can do it in cross sections, which is meant for, on one side, to create these feature lines, but also, if necessary, if there was some noise during the measurement, so you can correct what has been already created. Yeah, so and you have really freedom to move it and to work with this. And you can go cross-section by cross-section, and you can check what's going on, how this feature line is created. Because many people prefer to work in cross-section, so we have also this functionality here. Yeah. And as I'm moving through, you know, so I am creating it, you know, every 2 meters, maybe width, I can change the width and so on and so forth, that these cross sections will not go too far away, you know, from the center line. So it's really up to me. And after having this, I can create what we call traverse points. So as I said, you want not only to export the horizontal features, but also these cross sections. So now I will say, okay, what will be the length, what will be the distance between the lines and vertices. So basically, how dense information will be when imported to Civil 3D. And yeah, voila, and you have these cross sections, which is in fact cross sections through existing ground. And now you are saying what you want to in fact take over to Civil 3D, in which coordinate system, and then you will specify obviously folder where you want to bring it, that you can later on in Civil 3D say, okay, bring the data from here. So this is how we are capable to process laser scan. Again, of course, it's you can imagine if it's and this is 5 kilometer road, with some side roads and so on and so forth. It can take some period of time. But important is that it's a really automated way of doing stuff. And you can imagine, because now you can see, for example, here, that central line is going this direction, obviously, then I have everything there. And this is what has been created. So basically, we are creating RCS files, but not only this, also shape files, which will be later on used in Civil 3D. So what are the benefits? So you can consume any data, including GIS, because if you are doing rehabilitation, maybe you want to know what is around. You can bring a conventional survey, basically standard survey using theodolite, for example, or total station, better said. You can use laser scans, drones, photos for wider area, and you have also capabilities to clean point clouds. And of course, prepare the data as you have seen. So let's move to the design. This is obviously, let's say, the most important step, but without proper existing ground conditions, so there is no good design. And, as I said at the beginning, road rehabilitation can have different flavors. So maybe you want to use do only some design speed. You want to do design speed improvements, which means that you will redefine alignment profile to meet really standards for higher speed. So you are in fact redesigning a road, including superelevation, widening, so on and so forth. Or you want to make just a resurfacing, basically scarifying the top layers and making overlay over this. Or it can be a mixture of both, so it really depends what you want to achieve, and you can do it. For this first part, we have obviously standard way of doing, but using advantages of best fit alignment, best fit profile, which will help you not to do it step by step, point by point, and I will show it to you soon. And with the resurfacing, it's more about intelligent sub-assemblies which can be utilized. And if we are talking about Civil 3D, because we are moving to the design stage, we have functionality for alignment and profile. I already mentioned for what we call best fit, so based on existing points measured, better said, which we extracted in InfraWorks, so you can create alignment and profile and redesign, so change radius and so on and so forth. And then we have different sub-assemblies, again, out of box, which you can utilize to make your design with parameters defined and etc. And then you will create corridor, you know, you can check it, change station by station, in fact, and you can have a look at it. You can modify, because as I said, you know, so maybe here you have to satisfy some constraints like entrance to the yard, etc. And then you can do report, because in reports you will see much better if you are exceeding some crossfalls, slopes, etc. And you can do using standard functionality of Civil 3D analysis, you know, where you will see where is the low point, where is the high point, where maybe the crossfall is not satisfying criteria, and you'll be in trouble with water, etc. So let's have a look to alignment. So we do have alignment creation tools like standard, fixed float, and free, but we do have also best fit, you know, so just to follow some objects which has been surveyed out in field. So let's have a look how we can look like what you can do. So imagine I brought this features into Civil 3D, and now I have it and I can work with this, you know. So now what I can do, for example, fix or floated line or curve based on these elements. So let's do this. Let's start as an example. I will pick this on the screen, but of course it can be already AutoCAD points or entities, you know, I can split it. So I have different variety of stuff what I can do, but me personally, I prefer, you know, to snap on the points which I can utilize, and I can see immediately, because I don't have really clue where the transition maybe starts, you know, so where is the beginning of the spiral, end of the spiral. But then manually I can say, okay, this is where I want to finish. And we do have this chart where you can see offset from the entity, and then of course it's up to you to make a decision if this point is some point which has been not measured properly, so I can exclude it. Or obviously if there is some breach on the way, which is something which you have to follow, it will be reconstructed. So then you can say that that the system has to pass through this point, because this alignment has to go through there, you know. So you have this possibility as well. And then obviously I will continue, so I know that there is a curve. And then, okay, I will pick again, you know, but now I selected floated in just to show functionality. And of course, system knows that it's floating to the previous one, and I'm picking the points. I see immediately again offsets, and then I can save it. Yeah, and same procedure, you know, so I can say, okay, this has to pass through this, and so on and so forth. But now let's imagine that this project is for resurfacing, and intentionally I don't do anything with profile, because profile will be a result of the resurfacing. So basically I'll build corridor based on alignment, based on existing conditions, existing road, and based on criteria, system will create profile. But of course, if you are making some improvement of the design speed, you should create best fit profile as well. And then what we have is corridor creation, where you can create a standard corridor, depending what you want to achieve. Or if you want to make only resurfacing, then you will use the rehab corridor. And also,
I również mam...
or sub-assemblies for specifically for rehabilitation, Or what you can use is subassembly composer. Basically, we are still giving you the possibility using some visual programming to program your own subassembly. But I will get to this. And then if you look to the standard subassemblies, it's about existing condition, maybe just doing some widening, maybe taking some out, adding. But this is, for overlay, milling, leveling, widening, matching the slope. So we have a different functionality here, which you can utilize. Then, as I said, we have also a possibility for subassembly composer, which means visual programming, and then we are offering you, or this tool is giving you different, let's say, possibilities how this subassembly should look like, and then you can create really stuff that, create this point on the cross-section based on this condition and so on and so forth. And of course, because it's programming, so then there can be decision, if this, do this, if not, do something else. So this is something which you can do, and then system is giving you immediately preview how it will behave. And of course, you can target it. You can target it to edge of the road and so on and so forth. So subassembly composer, very useful tool. And then what we have is really rehab subassemblies, rehabilitation subassemblies, and one is specifically for overlay and level. Second one is for overlay and milling, and the third one is in fact overlay, milling, and leveling. So all three. So you have this. Obviously, there is help related to this, but now let's have a look how it can look like. So if you have your alignment, which we created, then you can create for resurfacing a new corridor, and I specifically created the rehab corridor, which is corridor. At the end it will be standard corridor, but created different way, and you will see in a minute what it means. And now I create rehab rehab corridor, and now I can see my profile. Excuse me. My profile. I can see my layout. And of course, in profile, it's only existing ground. In layout, I have my existing condition plus best fit alignment, and then I have a cross section. And now I can define parameters for a rehab corridor, which means what is the lane offset, or if I want to target it on the left-hand side and obviously on the right-hand side. So now I will use functionality of Civil 3D because I want to target it. I don't want to make any widening. This is existing edge of the road. So I can say, okay, this is where I want to finish on the left-hand side. And then similarly for right-hand side, I will specify, okay, let's finish it here. So these are my, let's say, constraints as far as width of my lanes are concerned. And then I'm defining other properties, so I can specify tolerances, because, if you are looking for surfacing, you can say that, okay, my crossfall can change plus minus 0.5% or something like this, because of course it has the benefit because at the end you will spend less material, so it will be more economical way of doing. You can specify overlay depth, minimum level depth. So basically you can define parameters how this resurfacing will behave, because of course you can say if you want to, because if the road is destroyed, you want to scarify something and then put over and so on and so forth. And the benefit of this rehab corridor is that you can see it here, that I can immediately see in cross sections what's happening, and these exclamation marks means that I am exceeding some values, you know, so some predefined values, for example, like crossfall, etc. But I can go through this and I can check what will be there, you know, with this particular standards which I have defined in properties. So because the beginning was not very nice because of survey, but now I can see that stuff is going pretty well. But if I change any parameter here, I have immediately, let's say, visibility. What does it mean? System will rebuild corridor and I put overlay. So if I will put after milling or scarification, I will put some overlay. What does it mean? Based on the given conditions, obviously. I can interrogate it, so maybe here I need more, so I will refine it so to satisfy the criteria, my design criteria. And you can see that this is the benefit of rehab corridor, because I can see immediately the results, what will happen and how it will behave. And then I have also a rehab manager, because I want to see these results not only graphically but also numerically, you know. So, and you can see station by station. I can see what is the slope of existing ground, what is the ideal slope which has been predefined. I specify the tolerance, what is the result, what is the difference. So, and you see that in colors. System is giving you overview what is over some tolerance, you know, so you can see that the difference is too big, so maybe you have to accept a different slope. So, and you can see that you can override it even here, you know, so and immediately I am in green colors, because now it makes much better sense. So you see that I am working really station by station. The first iteration is done automatically by software, but then I can go through this and I am working on model, which will be at the end, again, dynamic model, you know, so I'll be able to create cross sections, etc. But I have this ability to work with this. And now I will use standard functionality of Civil 3D because maybe I want to use a different style coming from Polish country kit, and maybe this is better for me because I see the elevations, I see the crossfall only in cross sections. So yeah, you have really flexibility and scalability in product, whatever you want to set up. And of course, if you are expert user, you can create your own style, whatever you want, because it's everything definable. Yeah. And we have also reporting, because at the end of the day, after creating the design, you want to report it out, maybe for setting out or for some different purposes. So we do have functionality to create different types of report. You can even write out to file what you have seen in previous video, you know, so there is this possibility. Or you can use standard functionality of Civil 3D to make report. Or of course, the easiest way is to give a surveyor the data from design, you know, and he will load it to his machine to either to set it out or to finish, you know, to make this what is necessary. First, of course, scarify and then to add, and so on and so forth. And don't forget, there is wide range of analysis where you can see, you know, what's happening, you know, so we have surface analysis. You can make difference analysis between two surfaces. So you have basically a possibility to visualize it a very different way, and you can see what's going on. And what are the benefits? I do believe it's really a versatile solution, and it will help you to really make the best out of your design. But obviously, it's only computer and software, and you have to make your decision. We are just helping you to make these iterations faster, but at the end you have to make decision. Okay, in this cross section it should look like this, in that cross section should look like that. And we are also checking longitudinal profile. So if you of course changing something in cross section, what is the result in a longitudinal profile that you will not do some bumpy road and so forth. And I was talking about some analysis, some predictability, because why I want to talk about traffic simulation, because in fact, if we are talking about road rehabilitation, you have to close the road. And then, of course, some people might get angry because then they have to queue in long queues. And this is why you can predict it, So basically, what you can do, you can analyze traffic flow after the closure, how it will look like, and you can make decision if some traffic should go different direction, or maybe you shouldn't close the entire road, but maybe some parts, depending on the possibilities. But we are giving you functionality which help you to create really first existing conditions from public available data, or of course you can connect to Polish GIS data, and you can make most probably not most probably, but definitely more precise data. But I don't think that for traffic simulation it's really necessary. But you can have very quickly in matter of 5 minutes the data, and this is part of Poland, is in southwest, which I have just created. And I just want to show you, let's imagine that you want to close this road and you want to make analysis, traffic simulation. And what you need is you have to define this traffic simulation. So you can specify what is which types of car are traveling there in percentage, small cars, medium cars, trucks, because of course each of them has different behavior and will cause different problems, Then you have what we call demand generation, where you can specify from where to where, what will be the approximate number of the cars traveling this direction. So you will have some metrics, that okay, from here to there it's going so many people, and then you can also specify what are the conditions on junction, if there is a yield sign, traffic lights, and of course it also depends how it will behave. And then system will help you to define and use all that kind of stuff. So let's have a look that here is this road which is out of our interest, and now let's see another road. So you can start traffic simulation. And traffic simulation is in fact a cloud-based solution which will use what we call cloud credits. And basically what's happening is that you are sending this part of land and traffic conditions, like which roads are there, to cloud, and it will bring you to traffic analysis software, where you can define different also how it will look like, because maybe for me it's much easier to visualize it this way, where I see how the cars will be traveling. I will create these demands, so I will specify which cars will be traveling there, and of course you can change it. It's editable, so I will say okay, there will be more trucks, so lower number of small cars by default, but of course now I can work with these metrics accordingly. Yeah, so yeah, let's go back to 30. And then of course defining what we call this division. Then you go to these demands, where you will have to specify, okay, from which point to which point, what will be, which cars will be traveling there. Yeah. So let's have a look. So you know that from there it's some approximate number, of course, you know. So you know that on this road in this direction is main city, you know. So there will be much more cars than in this direction, and so on and so forth. So of course, although these cars will need to travel there, you know, so you are adding just to this road additional traffic. So you have to specify all that kind of stuff. And then let's have a look to some intersection, you know. So you can specify in the intersection, as I mentioned, you know. So you have different turns from which direction to which direction, because from GIS data you have also the name of the streets or the name of the road. Then you will say if there is a stop sign, if there is a yield sign, or if there is traffic lights. And of course, if there is traffic light, then you are specifying how long red light will be there, how long green light will be there, and so on and so forth. So yeah, it will take some time, but on the other hand, you can imagine that you will get very good understanding what will happen, and if this junction will not cause the issues later on. And of course, then you can specify other junctions as well, you know. And then, you know, you can specify if you say traffic lights, as I said, timing, how long will be green, yellow, red, you know. So you can specify obviously different numbers based on the conditions. But don't forget, then later on you can say, okay, it will be a better solution if we will change traffic lights, you know, maybe more green here because of changes, changing of the traffic, maybe more red in different direction. So it's really entire up to you, and you will be able to make this informed decision because you will have understanding why it's happening. And then, you know, system will preview what's happening, you know, and you can see that because of some amount of the cars, if you will have some problems or not. And it's not only about this, because now you see just cars traveling, and of course, because I specify it will be short morning, just you know, 60 minutes in the morning in the traffic. So you see that more cars will be traveling there, and what will happen later. And it's just one view, because later on, yeah, my road is not the best one because I forgot to clean it. But anyway, you know, it's just giving you idea what's going on. And then, you know, if there is traffic light, again, there's red light, and from this direction, not too many cars are going, so it doesn't make too much sense. And of course, you can imagine that if there is some problem, you know, so there will be really cars which will start to travel there, but because of, you know, queuing already here, there will be problems. So just understanding this, and of course you can change it, and you can check what will happen if. And later on, at the end of the day, you will be able to see also some overview, you know, so this blue and red color, you know, so what, how many cars will be there, what will be the waiting time, and so on and so forth. And it will really help you to predict what will happen there after road closure. I know this is not topic maybe for road designers, but I wanted to give you overview of entire functionality which we are offering for road rehabilitation. And obviously, if you are working, let's say, in city, maybe this is something which might be out of your interest. So with that, I would like to thank you for your time. Thank you for listening and attending this session. I hope it was useful. And obviously, if you need to know more information, please do not hesitate to contact our partners, accredited partners, certified partners, which will help you with the solution. With that, thank you very much and have a good day. Bye.
Hello, thank you very much, Tomas. Of course, it was interesting. And that's a great news that Autodesk has some solutions also for rehabilitation of roads, not only for designing. That's a really good option.